Hi, I'm Tom Stone, the National Sales Manager of Industrial Markets for Thermal Care. Thermal Care has been in the process cooling business for over 50 years and serves over 50 different industries.
So next, as the part of selecting the right chiller, is the type of condenser. And these are things that need to be considered beforehand so that you ensure you're going to be getting the right type of chiller to suit your facility's ability to support it. We're going to start with the integral water cool. And so as we can see here in this little diagram, there's a water-cooled chiller listed there, and it has four lines coming in and out of it, the red and the blue, which is the chilled water. And as we can see, that goes through with a pump tank and then circulates out to the process load, that orange cube there, the smaller one. So that's the chilled water side. A chiller, any chiller that we have is going to do that. But what's unique about a water-cooled chiller now is that it's using a different water source to actually pull the heat out of the chiller that the chiller has removed from the process. We use typically a cooling tower for this, and a cooling tower uses evaporation rather than refrigeration. And so while it can still reject heat, it can only achieve about an 85-degree temperature, whereas a chiller can go much lower. So what this allows us to do is use our chiller, but then also use this higher level of temperature water available to reject the heat. It's a very efficient means of doing it, but now you have to consider a whole nother basically infrastructure system of a cooling tower system to support that chiller. So if this type of system already exists in your facility and you just want to add the chiller on, that may be a very viable solution for you. And that's why we would offer a water-cooled unit. If none of that exists, you really don't want to start to build a whole extra infrastructure just to support your chiller infrastructure. So that's where we would start to talk about these next two. The first being an integral air-cooled, which would be kind of like a packaged unit. And so what we've shown here is this is actually an outdoor air-cooled unit with a separate pump and tank system. That pump and tank system could actually still be incorporated into the chiller itself, but here it does a good job of illustrating how the components work together. With that outdoor air-cooled unit, the integral air-cooled unit, we have those fans that are depicted there. And what those fans are actually doing is they're forcing air over a air to refrigerant heat exchanger. And so as that air is forced across there, it pulls the energy out of the refrigerant and allows that refrigerant to then cycle back through its refrigeration cycle to cool the process water. Those air to refrigerant heat exchangers act a lot like a radiator in your car. They're using fans with forced air to remove the heat. With those, you have additional motors running, so you have additional electrical draw, and so the units aren't quite as efficient as, say, a water-cooled, but they have a lot of other benefits, like you don't need that cooling tower infrastructure there. You don't need any sort of the treatments and the chemicals and the consumption that a cooling tower system has either. So there are a lot of benefits. These a lot of times could be very much a plug and play setup, especially if that pump and tank is incorporated into the chiller itself. It's a packaged unit. You plumb it up, you put power to it, and it's ready to go. So that's one of the very nice things about these units. The next step would be a remote air-cooled unit. And with the remote air-cooled unit, we've essentially taken the chiller and we've separated into two pieces. We have the condenser and then the chiller itself, where it has the compressor. What we're showing here is this is a remote air-cooled unit, and the condenser is located outside. It still has the fans. It still has that air to refrigerant heat exchanger using forced air to cool. So very exact same concept as the integral unit. We've just separated them into two. And what that allows us to do is leave that chiller indoors. So one, you can have access to it while we're still ultimately rejecting the heat of the system outside. So we're not putting any sort of heat load on the HVAC system. We're not building up heat in the facility. But now we have the chiller inside, so we don't have to send any water outside. So now we've avoided the glycol issue. The main downside of a remote air-cooled system is that now you have to connect that condenser to the chiller. and that's done with refrigerant piping. So that's copper piping. And that requires a additional installation by a certified refrigeration technician. So that installation can be a little more costly. Also, you're a little limited in how far those two pieces can be from one another, how they can be relative, different planes, one up on the roof, one down below, things like that. So there's more considerations to take in when you're looking at a system like this. But it does have the benefits of you can avoid glycol, you're still discharging your heat outside. So there are benefits to all three, of whether it's a water-cooled, an integral air-cooled, or a remote air-cooled. And you need to consider your exact facility's demands to best determine which way you want to go. I hope that helps you guys, and thank you for your time.